Hello everyone, welcome to this video lecture of Irrigation Engineering. This is Sukamal Ghosh, Assistant Professor, Civil Engineering Department, Greater Kolkata College of Engineering and Management, JS Group. This is our second lecture on methods or the techniques of irrigation. Now in this particular video, we are going to discuss about the remaining techniques or the methods of irrigation which was not covered in our earlier lecture. So as we know, in our earlier lecture we have discussed the flooding method of irrigation. Now in this particular video we are going to cover the furrow method of irrigation, the contour forming method of irrigation, the sprinkler irrigation and the drip method of irrigation. This subsurface irrigation has already covered in our past lecture of type of irrigation. So let's discuss first about the furrow method. So in the furrow method of irrigation, water is applied to the land to be irrigated by a series of long and narrow field ditches which are excavated between the rows of plants, and this narrow and long field channels are known as furrows. Okay, and this furrows carries the irrigation water in the field. Now various row crops such as potatoes, maize, cotton, sugarcane and various vegetables such as onion, then carrot, this can be irrigated by furrow method. Apart from that, some other crops such as sugar beet, groundnut, then tobacco, this can be also irrigated by this furrow method. Okay, so in our earlier lecture where we have discussed the various flooding technique, we have seen that in flooding method or in flooding techniques the water covers the entire surface, but in this furrow irrigation method only 1/5 to 1/2 of the land surface is wetted by the water. It means only 1/5 to half of the land is get wetted in this furrow irrigation, which results in reducing the evaporation loss. Thus, furrow irrigation avoids the flooding of the entire field surface by channeling the flow along the primary direction of the field using this furrows, which can also be called as grooves or lines. Okay, now so this is a plan view of a portion of an agricultural field where the furrow irrigation method has been adopted for supplying the water to the crops. You may observe in this particular figure, this long and narrow field channels or the ditches are known as furrows, and the crops are growing between the space of the furrow, means here. Let me change the color. So crops are growing here. Okay, in this green portion the crops are growing. And the water flowing through the furrows infiltrates into the soil and spread laterally to irrigate the land between the furrows. Okay, see, this is a cross section of this plan view. Okay, you can see here these are the channels. Okay, let me change the color. So these are the channels and water is flowing in these channels. Okay, and the water infiltrates through the soil and spreads laterally, and thus it irrigates the crops. Okay, you may see here this is a picture of an actual agricultural field where the furrow irrigation method has been adopted for supplying the water to these crops, and this long and narrow field channels or ditches are furrows. Okay, and you can see here the water is flowing through this furrows. Okay, now so the furrows may be classified on the basis of their alignment into the straight furrows and the contour furrows. The straight furrows are aligned along the more or less parallel to the straight lines, and these are laid along the slope of the land. Generally, the straight furrows are best suited where the land slope do not exceed 0.75%. Okay. Now the contour furrows are aligned along the contours, and hence these are laid across the slope of the land. These furrows are therefore curved in plan and are usually adopted where the lands to be irrigated have relatively steeper slopes. Now the design criteria of both type of furrows is the same. However, in the case of the straight furrows, the supply channels or the pipes are provided at the upper end of the field. But for this contour furrows, supply channels or the pipes are aligned along the slope of the land. Now, the spacing of the furrows is determined by the spacing desired for the rows of the crops, because in most of the cases, one furrow is provided for each row of the crops. The crops like potatoes, maize and cotton are planted 600 to 900 millimeter apart and have one row of crops between two furrows. However, vegetable crops such as carrot, onions, etc. are spaced 300 to 400 millimeter apart and often have two rows of the plants between two furrows. Thus, in each of these cases, the furrows spacing may be 600 to 900 mm. Thus, in each cases, the furrows spacing may be 600 to 900 mm. In orchards, furrows may be spaced 1 meter to 2 meter apart, and in some cases the spacing of the furrows may be as such as 3 to 4 meters. Okay, so for the orchids, the spacing of the furrows may be from 1 meter to 2 meter to 3 meter to 4 meter. Okay. Moreover, certain wide spaced crops such as watermelon, fruit trees and berries generally requires more than one furrow between the two furrows of crops. In general, furrows should be placed close enough to ensure that water spread to the sides into the lands between the furrows and the root zones of the crops to replenish the soil moisture uniformly. Okay. Now, so the shape and the size of the furrows mainly depend on the soil conditions and the type of the crops. In general, the furrows used are either U-shaped, V-shaped, parabolic shaped or trapezoidal shaped as per the requirements of soil stability. Now, if you consider the size of the furrows, then we should know for soils of low permeability, a wide and shallow furrow is preferred since it gives more area for the water to infiltrate. On the other hand, when the soil is quite high permeable, a narrow and deep furrow may be used to avoid the excessive percolation at the upper end. However, in general, the wide and shallow furrows are preferable. Okay, so let me write it here. The wide and shallow furrows are preferable. Okay. Further, furrows of 75 to 125 mm depth are suitable for vegetables and other row crops such as sugar beet, potato, cotton, tobacco, etc. While for other row crops and orchids, furrows of 200 to 300 mm depth are required, especially when the soils are of low permeability. Okay? Now, so the slope of the furrow controls the velocity of flow of water in the furrows. Thus, the steeper slopes lead to higher velocity of flow of water in the furrows, which may result in more erosion of soil in the furrow. Moreover, as the furrow slope increases, the rate of infiltration slows down and the side spread of water into the land decreases, with the result that wastage of water may occur at the end of the furrow. Now, if the furrow slopes are too less, then proper surface drainage may not take place and it will result excessive deep percolation and hence water will loss. In general, the ranges of slopes as recommended for the border strips in different soils apply to the furrow irrigation also. Further, a minimum furrow slope of 0.05% is needed to ensure the proper surface drainage. However, in the soils having very low infiltration rates, the furrows are usually level without any slope being provided along their lengths. These furrows are known as level furrows, in which the water is ponded until it is absorbed by the soil. Okay? So, in level furrows, the water is ponded until it is absorbed by the soil. Okay? Now, the length of the furrows should neither be too long nor too short. This is so because if a furrow is too long, water may infiltrate to a greater depth at the upper end of the furrow, and by the time it reaches the lower end, this results in excessive deep percolation losses and over irrigation at the upper end of the furrow. On the other hand, short furrows require supply channels to be spaced too close, with consequent loss of land and increase in labor requirement. This particular table may serve as a rough guide for selecting the length of the furrows. From this table, you may have an idea that the length of the furrows depends upon the slope of the furrow, the type of the soil, and the net depth of the water application. So you may observe, with the increase of net depth of water application, the length of the furrow is also increasing. Okay? You may observe that for 0.05% of slope and for a depth of 75 mm of water, the length of the furrow is 300 meters. But if we increase the net depth of water application from 75 to 150, then also the length of the furrow increases to 400. Okay? In this way, in every row, you may observe that if you increase the net depth of water, then also the length of the furrows increase. Now, the furrow length is considerably affected by the permeability of soil. Thus, furrows must be shorter for the porous soil, means for the sands, the length of the furrow must be shorter, right? Because we know within clay, loam and sands, the sand is more porous. So, the furrows must be shorter for the sandy soils compared to the tight and heavy soils like clay and loam. From this table also you can understand, for same specifications, means for same slope and same net depth of applied water, the length of the furrows for sandy soils are less compared to the loams and that of for clay soil. Okay. Now you may also observe the furrow length increases with the slope of the furrow up to 0.30% slope. Let me clear it so that you can understand it better way. See, up to 0.30% slope, the length of the furrows increases with the increase of furrow slope, but the slopes steeper than 0.30% means for the slope of 0.50 and 1, a shorter length of furrow is used. Okay. Now, so the contour forming method of irrigation is practiced in the hilly region where the lands to be irrigated have the steep slopes with the falling contour. Okay. Now, in this method, the land to be irrigated is divided into series of horizontal strips which are usually known as terrace or benches. Okay. And small bunds or the levees are constructed at the end of each bench or terrace to hold the water up to the equal height. This terrace or the benches are aligned to approximately follows the different contours at a vertical interval of 30 centimeter to 60 centimeter. Okay. You may observe in this particular cross section that these portions are known as terrace or the benches. Okay. And these are the bunds or the levees which are constructed at the end of each terrace so that they can hold the water up to equal height. You may also observe in this particular figure, these are the benches or the terrace. Let me change the color. See, these are the benches or the terrace. Okay. And these are the bunds or the levees to hold the water up to equal height. Now, each of these terrace or the benches or the strips forms an independent portion of the land to be irrigated. Thus, in this case, shown in this particular figure, a series of steps are formed in successive elevation around the slope. You may also observe in this particular figure too, these are the series of steps which are formed in successive elevation around the slope. Now the strips are level in the direction of the original land slope but are given a gentle slope along their length to ensure the efficient irrigation and drainage of excess water at non-erosive velocities. Now the height of these bunds should be sufficient to safely contain both the irrigation water and the rainfall runoff. For applying the irrigation water to this terrace, any of the methods such as border strips, furrow or check basin can be used. Okay. Now, in the sprinkler irrigation method, the irrigation water is applied to the land to be irrigated in the form of spray, somewhat as in ordinary rain, and the spraying of water can be performed using the network of pipes, pumps, nozzles, etc. And since this sprinkler method of irrigation is kind of an artificial rain, it provides a very good result. Sometimes it is also known as overhead irrigation. Okay, overhead irrigation. You may observe in these pictures that water is spraying to the agricultural field using the various network of pipes, nozzles, pumps, etc. Okay. Now, so there are various conditions which favors the adoption of this method. When the land topography is irregular, we can adopt the sprinkler method of irrigation, because when the land topography is irregular, it is unsuitable for the surface irrigation. Also, when the land gradient is steeper, means the slope are excessive, we should adopt this sprinkler irrigation method. Now, if the soil is easily erodible or erosive, then in that particular land, the sprinkler irrigation method can be useful. Now, also a land which has an excessive permeable soil is not suitable for surface irrigation, and thus the sprinkler irrigation should be adopted. Apart from that, the crops which are having shallow roots, to irrigate those crops, the sprinkler irrigation method is very useful. Now, when the crops to be grown are such as to require humidity control, such as tobacco, okay, we may adopt this sprinkler irrigation method. And for obvious, the areas where the seasonal water requirement is very low, we can adopt this spraying method or this sprinkler method of irrigation. Okay? Now, so the components of a sprinkler irrigation system are main pipelines, or you can simply call it as mains, then the submain pipelines or the submains, then the lateral pipelines, which is simply called as laterals, the riser pipes or the riser, the sprinklers, and the pump unit. You can see in this picture, this is a layout of sprinkler irrigation system, where this is the pump, okay, and this pump lifts water from the source. In this particular case, this well is the water source. So this pump is lifting the water from the source and supplies it through the pipes. These are the various pipes. These are the main pipes, submain pipes, the laterals, okay, and these are the risers, okay. These vertical pipes are the risers. So the pump supply the water through the pipes to the sprinklers, okay. You can see here, these are the sprinklers, okay. This sprinkles or sprays the water to the crops, okay. Now there are three types of sprinklers, okay. The first one is fixed nozzle pipes, the second one is perforated pipes, and the third one is rotating sprinkler, okay. Now this fixed nozzle pipes are the type of sprinkler which consists of the lateral pipes having a line of small holes drilled at the top at some regular interval along their lengths, and on each of these holes small nozzles are fitted. Now a series of such pipes are installed parallelly to each other at a distance of about 15 meters apart and are supported on rows of posts. The spray of water is developed through the nozzles, and the entire 15 meters width between the pipelines may be irrigated by turning the pipes through 135 degree, okay. Now this fixed type nozzle pipes are kind of old sprinklers. This type of sprinklers are not used this day, okay. So these are old type, okay. Now these perforated pipes are the type of sprinkler which consist of a lateral pipe having perforation or small holes drilled along their top and sides in a specially designed pattern to distribute water fairly uniformly, okay. A series of these perforated pipes are laid parallel to each other on the ground surface. Through the perforation, sprays of water are developed which are directed on both sides of the pipes and can cover a strip of land from 6 meters to 15 meters, okay. Now in this case, the minimum rate of application of water is about 20 mm per hour, okay. Now since the water is applied at a relatively higher rate, these sprinklers are suitable for soils having moderately high infiltration rate. Okay, so the perforated pipes are suitable for the soils having high permeability. Okay, so let me write it K. K is the coefficient of permeability, right? Now this rotating sprinkler consists of one or two nozzles mounted on a body which is rotated slowly about vertical axis by the action of a deflecting vane connected to it. So if this rotating sprinkler consists of one nozzle, then it is called as single nozzle rotating sprinkler. But if it consists of two nozzles, it is called twin nozzle rotating sprinkler. Okay, now so these are various pictures of the components of the sprinkler irrigation in real agricultural field. You may observe here, this is a main pipeline or simply mains. Okay, and this can be a sub main. Okay, this is a lateral. Okay, and this is the riser. Okay, see, this is a riser and this is the sprinkler. Okay, you can see here in this particular figure also you may see a sprinkler. Okay, and as we discussed in our previous slide, we may have two different kind of rotating sprinkler. You may observe in this particular figure, this is a single nozzle rotating sprinkler because this particular rotating sprinkler consists only one nozzle. Okay, but this is a figure of twin nozzle rotating sprinkler because this particular rotating sprinkler have two nozzles. Okay, now as I discussed, the rotating sprinkler, this is also a rotating sprinkler. Okay, so as I discussed that the rotating sprinkler rotates slowly about the vertical axis by the action of a deflecting vane connected to it, right? Now the motion of the vane is restrained by light springs. Okay, so these are light springs which tends to bring it back to the original position, but the return of the vane is terminated by a stop on the body which thus rotates through a small angles by the impulse. Okay, now the vane again interrupts the jet and the cycle repeats. Okay, so the spray of water is developed through the nozzles and it is sprinkled over a circular area of the land to be irrigated, which is covered by each sprinklers as it rotates. Okay, now these rotating sprinklers are used very extensively for irrigation almost all types of crops. Now, so based on portability, the sprinkler irrigation systems are classified into the portable system, the semi-portable system, the semi-permanent system and the permanent system. So a portable system has the main pipelines, sub-main pipelines, the lateral pipelines with sprinklers and the pumping unit portable. Okay, it is designed to be moved from one agricultural field to another or to different pump sites in the same field. The portable system may be designed to be moved manually or by mechanical power. The system operated manually is known as hand move system. Okay, and in this hand move system, the mains and the lateral pipelines are moved manually. On the other hand, the system which uses the mechanical power for moving the lateral pipelines is known as wheel move system. Okay, now in wheel move system, the entire lateral pipeline is mounted on wheels and it is moved as a single unit instead of moving separate pipe lengths by disassembling the lateral pipelines. Okay, now a semi-portable system is similar to fully portable system, except that the location of source of water and the pumping units are fixed. As such, this system may be used on more than one agricultural field where there is an extended main pipelines or there are additional pumping units. Okay. Further, a semi-permanent system has a portable lateral pipelines with sprinkler, but the main and the submain pipelines are permanently laid and are usually buried. Further, the source of water as well as the pumping unit are also fixed. Okay. Now for the permanent system, basically all the components are fixed. Okay. This fully permanent system consists of permanently laid mains, submains, lateral pipelines and the source of water as well as the pumping unit are also fixed. The mains, submains, the lateral pipelines are usually buried below the flow depth. The sprinkler are also permanently located on each risers. Basically, the sprinkler installation in orchids are usually of the permanent type, though this permanent system is very costly. Okay. Now, so the sprinkler method of irrigation has tons and tons of advantage or benefits compared to the surface irrigation. In sprinkler irrigation method, the land preparation, let me change the color. So this land preparation means the leveling of the land, then making a suitable gradient. These things are not required unlike the surface irrigation, and due to this reason the labor cost is reduced. Apart from that, since in sprinkler irrigation method the border and ditches are not required, so no cultivation area is lost for making the ditches or the borders, unlike the surface irrigation, and it results in increasing the crop area. So the more land will be available for cropping. Now in sprinkler system of irrigation, the water is to be applied at a rate lesser than the infiltration capacity of soil, and thus the surface runoff can be eliminated and washing of the top soil or this erosion can be controlled. Also, the seepage losses which occurs in earthen channel of the surface irrigation methods are completely eliminated. Further, the fertilizers can be uniformly applied because they are mixed with irrigation water itself. Now very small streams of irrigation water can be used efficiently and it will result the more land available for the cropping. And last but not the least, up to 80% efficiency can be achieved. It means up to 80% of applied water can be stored in the root zone of the plants. Okay? Now, though the sprinkler method of irrigation have dozens of advantage or benefits, it has some limitations too. A high wind may distort the sprinkler pattern and it will cause non-uniform spreading of water on the crops. Now, in areas of high temperature and high wind velocity, considerable evaporation loss of water may take place. Further, the sprinkler irrigation system is not suited to the crops which required frequent and larger depths of irrigation, such as paddy. Okay? Apart from that, only sand and silt or other dust particle free clean water must be used in the sprinkler irrigation system, otherwise the sprinkler may be blocked by the dust particles. Also, the sprinkler irrigation system required large electrical power and constant water supply, and it may causes interference in farming operation due to its network system. And last but not the least, the initial cost is very high in case of sprinkler system. Also, heavy soil with poor intake cannot be irrigated efficiently using this sprinkler irrigation system. Okay? Now, so the drip irrigation, which is also known as the trickle irrigation, is one of the latest irrigation technique, and it is meant for adoption at the place where the acute scarcity of irrigation water exists. In this method, water is slowly and directly applied near the base or to the root zone of the crop, and thereby minimizing the losses by evaporation and percolation. Now the main components of drip irrigation system are the pumping units, the main pipelines, the sub-main pipelines, the lateral pipelines, and the drip nozzles or the emitters. Okay, the applied water in drip irrigation method oozes out of these small drip nozzles uniformly and at very small rate and directly, as I discussed earlier, into the crop roots area. Okay, now so this is a layout of drip irrigation system. You can see here, this is the pump which lifts the water from the water source, which is in this particular case is a formed pond, and supplies the water through these main pipes and these laterals to this drip nozzles or the emitters, or you can say the drippers. Okay, so basically this is the main pipeline and these are the laterals and these are the drippers. Okay, and these are some pumping units. Okay, now so here is some pictures from actual fields. You can see here these are the laterals. Okay, this is also laterals, and this is the drip nozzle or the emitters or the dripper, and from this drip nozzles the water oozes out and drips the water at the root zone of these crops. Now these emitters or the drip nozzles are so designed that no jet of water is issued by them, but they allow water to emit or trickle through them. Further, the emitters or the drippers are provided at regular intervals on these lateral pipelines. Okay, and the spacing of these emitters are adjusted to produce either a weighted strip along the rows of the crops or a weighted bulb of soil at every plants. Okay, now as we can see in this particular figure, usually one lateral pipeline is provided for each row of crops. Okay, now all the pipes, it can be the lateral pipes, the sub-main pipelines or the main pipeline, whatever the pipes are, they usually made of black PVCs. Okay, black PVC tubing. Okay, this emitters also made up of PVC materials. Perfect. Now, so the drip method of irrigation has several advantages or benefits. Less water is required for this type of irrigation. Apart from that, waterlogging can be avoided if we adopt the drip irrigation. Also, the crop yield is very high in case of drip irrigation. The over irrigation can be avoided. Also, if we adopt the drip irrigation, it will increase the NCA, means the net irrigable area. And one of the important fact is it reduces the labor cost, and the drip irrigation method is suitable for any of the topographies. And if we adopt the surface irrigation, the soil may wash out due to high velocity of water if we provide a steeper slope. But in the case of drip irrigation, the washout of the soil can be prevented, and that is why the nutrients of the soil can be prevented for being washed out. Okay, now this is also a process of drip irrigation. In this process of drip irrigation, what people do, they make small holes in these bottles and water drips in this plants. So this is another way of drip irrigation. Okay, now so the main problem associated with the drip method of irrigation is its high initial cost. Apart from that, it also has a danger of blockage of the drip nozzles or the emitters. Okay. So this is all about the methods or the techniques of irrigation. From our next lecture, we will discuss a new topic, which is water requirements of crops. Till then, stay safe and stay happy. Thank you.